So this is the second part of the screencast for 1.5. This is page 29. Okay, so example 4, graph each function. Notice these are piecewise. What we've done so far was use piecewise where it was like lines or constants. Now I'm introducing some funky things like absolute value and square roots. Crazy. So I'm going to divide this piecewise graph into 3 parts because there's 3 different pieces. There's 3 different functions. So first, I'm going to look at this one. And what we do to graph the piecewise is I'm going to plug in my endpoint and find a value. So f of 0 is going to be, let's see, negative 0 plus 3 is just 3. So at 0, 3, I have a point. Is it going to be an open circle or closed? Think to yourself. Don't say out loud. Don't say out loud. Think. It can be open or closed. Turn the person next to you. Aha! The choir says open. Tall. Why is it open? Right. So this is a point. This is 0, 3. So it's not an interval. But you said it's not or equal to. So if it's an equal to, closed circle filled. This is an open. So at 0, 3, I have a open circle. That's a really big open circle. Hold on. Open circle. Oh my god. Why is this pen so fat? Hold on. Open. Okay, you can see the open. So, okay, and I need another point. Because what's the shape of negative x plus 3? Flat, curve, circle, whatever. What is it? Louder? It's a line. It's a line, negative x plus 3, so it's going to be a straight, but where is it going? Right, the slope should be going down. Let's pick a point. I'm going to pick negative 1, right? Because negative 1 is less than 0. So I have a negative of negative 1 plus 3 is going to be 4. So I have a point at 1, 4. And then this helps me because I know it's a line. Now I have 2 points. I just have to connect them. Nope, because negative 1 is less than 0, so it's fine. But 0 is not less than 0. So at x equals 0, I have an open circle. And of course, my open circle should be smaller, but I'm trying to make it so you can see it from the back of the room.
Why would it be negative 1, 4? Wouldn't it be on the other side?
Sorry, this is negative 1, 4. I plugged in negative 1, 4. Okay, so this is part 1 of my graph. How many parts do I have? 3. There's 3 parts. There's 3 different functions. Okay, that was see if you're awake. What? Closed where? Negative 1, 4?
Yeah.
So negative 1 is less than 0. That's true, so it's included. 0 is not less than 0, so that's why I have open. 0 is not part of x is less than 0. So now I'm going to have a second part of my graph, which is, hold on, let me change colors. Let's have it be this one. Okay. So this is my second part, and I want to know, okay, 2x. What does this look like? Is it a parabola, a circle, a square root? 2x is a line. It's going to be straight. So if I know where I start and I end, I just connect them and make a straight line. Does that make sense? No? Okay, cool. So I'm going to plug in my 2 endpoints in for x. F of 0 is equal to 2 times 0, which is 0. So I have a open or closed circle at 0, 0. How do you know? Because it's an equal to. So I have a closed because it's equal to. And then when I plug in 3, 2 times 3 is 6. So at 3, 6, is it going to be open or closed? It'll be open. Because it's only a less than, it's not or equal to. So I want you to put those 2 dots on your graph, connect them, and then discuss how you would do the third part. All right, so let's put our 2 dots on our graph. So 0, 0, closed. 3, 6, open. And I am connecting them with a straight line. Is that, did I count right? No, I did not. Oh my gosh. There. Okay, so that's my second interval. Now this third one, it's a square root. That's so weird. Square root. So I need to plug in my endpoint. So f of 3 is equal to root 3 plus 1, so that's just root 4, which is 2. So I have a open or closed circle at 3, 2. What do you think? Who can I ask? Daniel, Latwin, open, closed.
Open.
Well, it's an or equal to.
Oh, so then it'll be closed.
Yeah, so it's a filled, a closed circle. So it'll be filled. So at 3, 2, closed. Okay. Do we know what this graph looks like? Square root of x plus 1. On a count of 3. Ready? Let's do it with our hands. 1, 2, 3. Hey, okay. Square root. Trying to help you understand what the graph should look like. So that way if you accidentally make a little mistake, you know what it should look like. These little quick checks, it's called like DIMS test. Does it make sense? Like, should my graph look like this? No, because it's a square root, right? Square roots are roughly looking like this. Okay, DIMS. Does it make sense? Does it look like what it should? And I just need one more point. So wait, x plus 1 is literally the square root of x, but shifted left by 1. Do you remember our x and y, like, parent function values? This is what we, like, semi-covered last time. All right, 0, 0, 1, 1, 4, 2, 9, 3. But wait, what we said was, this was 3, 2, right? Everything's moved left by 1, so what's my other point I could include? 8, 3. Oh my gosh, you guys are doing great. 8, 3. And that way I like, my square root was actually part of the square root. Okay. Let's pause for a second here.
Is it also closed?
Yeah, because 8 is greater than 3, right? X value of 8 is greater than 3, so it's actually included. Okay, so now we're going to deal with a piecewise where it's really only absolute value and square roots. So it's a little harder than what we've been doing. Okay, so I'm going to keep the same colors as last time. So first, I'm going to deal with the first interval. So I was color coding like the different ones. So the first one, I have absolute value of x plus 2, and this is when x is less than 0. Do you know what this looks like? What is this? Absolute value, and it's a v. What does the plus 2 do? Left. Left 2. Okay. So I have absolute value, just shifts it left by 2, so it looks something like this. What? Why did I not continue? It's only when x is less than 0. Okay, so I know it's going to be an absolute value function, shifted left by 2. So normally my vertex is at 0, 0, shifted left by 2. Am I going to have an open or closed circle at x equals 0? Open. Okay, so let's go through how we found that. So I'm going to say f of 0, I'll plug it in. Absolute value of 0 plus 2. Why is this not working? I literally just put a new tip on my pen. I don't know. Absolute value of 2 is 2, so I have a point at 0, 2, but it's going to be open because it's not an or equal to. We had to use our transformations to understand that the absolute value function, it's not starting at 0, 0, shifted to left by 2. And then it's just a regular absolute value where we go over 1, up 1, over 1, up 1, over 1, up 1. So I'll do it again. So you move your vertex over to negative 2, 0, and then you go over 1, up 1, over 1, up 1, over 1, up 1. Okay, that was the first one. Do you guys want to try drawing the second? Hey. Yeah, okay, so try the next one. This one will be a little simpler because I'm only between 0 and 2.
Why didn't you find a second coordinate for the first thing?
Well, because it's, you could find a second coordinate, but it's not just going to be a line for the first one.
Okay.
Because it's an absolute value, so it's a v. Yeah. This one's a v as well. Well, do we roughly know what this is going to look like before we even plug in numbers? So it's absolute value of x minus 2. So the minus 2 is going to shift it down by 2. So you have your v, and then you shift it down by 2. Okay, we can do that. So absolute value is 0 minus 2. It's just negative 2. So 0 comma negative 2. And this is going to be open or closed at this endpoint of x equals 0. Closed. It'll be filled because it's or equal, right? Because what's the actual y value when x is 0? Oh, it's going to be negative 2. And if I plug in f of 2, so I have 2 comma 0, but it's going to be an open circle because it's just a less than. It's none or equal to. So I have a point at 0 comma negative 2 where I'm having a filled. Then at 2 comma 0, I have an open circle.
How did you know to plug in 2 then?
Because those are my two endpoints. Like this is for x's between 0 and 2. Okay. But it kind of makes sense because this is part of the graph that looks like this. Let's see if I can do this. All right, so that orange v that I just drew, like that would be what the actual function would be, but I only want a piece of it. That's why it's called a piecewise, because I'm only taking a piece of that one to put on my actual graph. Okay. It's like we're making a collage, right? So when I was a kid, there wasn't nearly as much fun stuff to do, but you could like use magazines, cut out, and like make a collage. I didn't do that because I wasn't crafty. I thought that was dumb, but my sister did it. So we're making a collage of a bunch of different graphs. It's like I printed a bunch of graphs and just like cutting them and making a graph yourself. Okay, let's do the next one. Lastly, square root of x plus 2 plus 2. Okay, first, before you even draw this, what would that transformation of this look like? What's happening? Of just a regular square root function, it's being shifted left by 2 and up by 2. Okay, so we know roughly what's going to look like. But we only want the portion when x is greater than 2. So, question, yeah? No? Okay. So let's see what the actual, like, I know this is going to be a whole because when x equals 2, I'm in the middle, right? The orange one. But I'm going to have an open circle. Let's see what the y would be if, when y equals 2 is actually, or when x equals 2 is actually using the bottom function. So let's find what f of 2 would be. Square root of 2 plus 2 and then plus 2. Square root of 4 plus 2, so that's 2 plus 2. Oh my gosh, so much math. 4. So this should be a whole, right? An open circle at 2 comma 4. So remember what we said? So we have the square root function, left by 2, up by 2. All right, we're taking the square root function, and we're moving it left by 2 and up by 2. So that's why it's like so high right now. And to make sure it's actually the right, we just need like one other point, so I just like connect it and make that curve. What would be another good point to include? 7. Who said this? Why? Why 7? Beautiful, right? We recognize I would like under a square root to be an actual square. So I'm going to pick f of 7. So square root of 7 plus 2. Plus 2. So that's square root of 9 plus 2. So that's 3 plus 2, which is 5. So I have a point at 7 comma 5. 7 comma 5. Wonderful. And then just connect them. Because 7 is greater than 2. It actually is in the interval. Awesome. Awesome, awesome. Okay. Let's go on. Last page of 1.5. Transformations with absolute value. So, it depends. Are you taking absolute value of your whole function, or are you only taking absolute value of your x? So what the absolute value of your whole function, what's happening here? Let me rephrase. So let's say this is like x squared minus 2. Right? This is f of x is equal to x squared minus 2. What you're doing is taking absolute value of your function values. So what that means is anywhere where a y was negative, right? Anywhere where it's negative, we're now making it a positive. So this would be g of x is equal to absolute value of x squared minus 2. Now, this is a little different than on the right side. So I'll show you what this means. So x equals, let's have this function be y equals x minus 2 squared. What happens is we are taking the absolute value of the x. So g of x here in my bottom graph would literally be the absolute value of x minus 2 squared. So what you're doing is you're erasing this left half, copying over, you're literally reflecting the right half of your graph over to the other side. Erasing the left half and copying the right half of your graph to the other side. Does that make sense? You're like, so when you have on the left side where you have transformation, where you have negative, you're taking the whole absolute value of the whole function, you're taking whatever was negative, popping it over the x-axis to make it positive. Versus, if you're only putting absolute value around the x, you're taking whatever's on the right half and reflecting across to your y-axis. Maybe. Have you guys done this before? No. Say no? Fun. Getting your money's worth today. Learning lots of stuff. So, perfect. Let's use a graph, f of x, to graph g of x equals absolute value of f of x and h of x, f of absolute value of x. Okay. Whew. First, why don't we graph the regular function first? Do we know what this looks like? Yeah? Let's see. Let me pick a nice color. Okay. So, f of x is equal to, how do I factor this? X minus 3, x minus 1. So the two zeros are going to be at 1 and 3. Okay. So 3 and 1. So 1 at 3. Okay. How mad would you be if I change this? I realize this is not going to be nice. I don't want to do that one. I'm going to pick a different one. I'm sorry. Made a mistake. Okay, f of x. Let's have it be equal to x minus 1 squared minus 2. Yeah, that's better. Where's my new vertex? Where's my new vertex? Down 2 to the right 1. Okay. And then, how do I actually graph it? So I move my vertex, and so the first point's over 1 up 1, the second point's over 2 up 4, the third point's over 3 up 9. How am I getting these numbers? Do we know? The parent function. So I have x, y. Normally I have negative 2, negative 1, 0, 1, 2, 4, 1, 0, 1, 4, because those are just the squared. So if I'm moving every single x to the right by 1, and then I'm moving them all down by 2. So I have a point at negative 1, comma 2, negative 1, comma 2, 0, comma negative 1, and negative 2, comma 7. I guess it's not one of them. That's better. That's much better. Okay, so this was my f of x. I want to draw my g of x. G of x is just going to be the absolute value of f of x. So what do I have to do? What do I copy over? What's the same and what's different? So if I'm just taking the absolute value of the whole function, whatever was negative is now going to be positive. So I'm taking this part down here, and I'm reflecting it across the x-axis. Otherwise, it will follow the same line as what we did before. This is the absolute value of the whole function. Versus if I wanted just the, versus if I want to do h of x, this is equal to f of absolute value of x. So what that does is you copy everything to the right of the y-axis So I'm going to copy this whole part and it turns more into a W. So it's very hard to see. It's very hard to see. I apologize for that. So the h of x looks like a W. Right? That's roughly what my h of x was. It's like a W. Oh my gosh. So my h of x looks like a W. My g of x, it like comes down and does this weird like, I don't even know what to call it. Is this clear what's happening? So when you take the absolute value of the whole function, whatever y values were negative, you reflect those across the x-axis. Versus if you're taking f of absolute value, so only you're doing absolute value of x, you're taking whatever's on the right side of your y-axis and reflecting it across. So this one will just take some practice. It's not as important as other concepts we learned, so just, try it out. We'll definitely go over it. Now to throw back to Fogg and Goff. Yeah. Remember Algebra 2? Composite functions? Fogg and Goff. Yeah, you're putting one function inside of another. Do we need more time to write this down? Okay. So, what I'd like you to do is like take a big breath in. Hold it, and now let it out. Look at all the stress leaving your body. Wonderful. This is fine. This is probably the first time you ever saw it, so it's going to take a hot second for you to actually comprehend it. All right, 1.6. Function operations and composition of functions. So if you are summing two functions, like how do you do it? Well, you literally add them, you subtract them, product. I don't know. This is literally, we've done this already. Let's just go through the example. We want to add these equations together. We want to subtract them, multiply them together, and divide them. So let's do the first one. Let's add them together. F plus g of x. What that means is you're literally just going to add f of x plus g of x. So x squared minus 2x plus 3x minus 4. Combine like terms. So I have x squared plus x minus 4. What is the domain for x squared plus x minus 4? It's a polynomial, so it's all real numbers. Because we're trying to find f plus g of x, f minus g of x, f times g of x, and f divided by g of x. And we have to state the domain of each new function. So the domain of polynomial, all real numbers. Let's do the second one. F minus g of x, yeah? F minus g. Why? It's not. If you look up here, f plus g of x is the same thing as adding, just adding them. F minus g, like this is the shorthand. It's just the notation. So if we're doing f minus g of x, all we have to do is take f of x and subtract g of x. So I have x squared minus 2x, and I'm subtracting 3x minus 4. So wait, if I am subtracting, I have to make sure to distribute the negative. So make that positive and make this just negative. So this turns into x squared minus 5x plus 4. What will the domain of this be? All real numbers, from negative infinity to infinity. Well, I reached a polynomial and I can't do anymore. Are you asking about when we like divide and multiply?
Yeah, how do we know that using factor?
It doesn't say factor, it just, like, we don't have to factor. We just have to combine all like terms. Okay, yes?
How do you find the domain? I'm so confused.
For polynomials, it's always all real numbers. Notice I don't have it's not a square root. It's not under a fraction. All right, third, f times g of x. What this means is I'm just taking my first function and multiplying by my second. So this is going to be x squared minus 2x times 3x minus 4. I have to FOIL this out. So I have 3x to the third. First, outer, minus 4x squared. Inner, minus 6x squared. And L last, plus 8x. So combine like terms. I have 3x to the third minus 10x squared plus 8x. And like I just want it simplified in the sense that you combine like terms. I don't need to factor it because I'm not trying to solve. It's not equal to 0. What will the domain for this be? All real numbers. Once again, this is a polynomial. Oh my gosh. Polynomial. So, if I want to find the next one, right, f divided by g of x, what this means is I'm taking f of x and I'm going to be dividing by g of x. So, let's see, this is just going to be x squared minus 2x over 3x minus 4. Can I simplify this at all? No, so this is going to be my answer, but I have to talk about the domain. What will the domain of this be? Well, I know 3x minus 4 cannot equal 0. So x cannot equal 4 over 3. Exactly. So we go negative infinity to 4 over 3, and I'm cutting out 4/3. So I have to have a union there, so then 4/3 to infinity. All right, so give B a shot. Try to do B. I'm gonna rope this, make it smaller. Oops, where'd that 3 come from? So f plus g of x is just f of x plus g of x, such as x over 4 plus 3 over x. I need to have a common denominator. So multiply by x over x, multiply by 4 over 4. So that's just going to be x squared plus 12 over 4x. The issue is, what is the domain of this function? What can x not equal? Right, x can equal 0. So I go from negative infinity to 0, union 0 to infinity. Do we understand why it's 0? Right, if I set the bottom equal to 0. Alright, so 4x cannot equal 0. Divide by 4 on both sides. You see x cannot equal 0. Cool. Try the next one. Yep. Yes. All real numbers. Because that would just be y equals 3/4.
Okay.
Just constant function. So f minus g of x. This is just f of x minus g of x. Such as x over 4 minus 3 over x. So I'm going to use the same numbers I did before, right? Because I have to multiply the left side by x over x, multiply the right side by 4 over 4. This is literally just x squared minus 12 over 4x. And it's going to be the same issue as before. The domain is just x can equal 0, so negative infinity to 0, union 0 to infinity. Questions over that one? No? Yes. Alright, third step. Let's do f times g of x. So that's f of x times g of x. Okay, so x over 4 times 3 over x. Oh my gosh, what the heck? It's just equal to 3/4. The x cancel out. Keep in mind, we're finding a new function. This is literally y equals 3/4, which you know is just a constant. It's a flat line. So it's the domain. All real numbers, negative infinity to infinity. Question? Andrew, question? No? Okay. And f over g of x. So this is just f of x over g of x. So x over 4 divided by 3 over x. That's the same thing. Dividing by a fraction is same thing as multiplying over the reciprocal. So this is just x squared over 12, aka 1/12 x squared, which is a polynomial. So the domain is all real numbers. Okay, hopefully that was a good little review. Okay, that's what I thought. Not too bad. So, composition of functions. These, okay, what we were just doing was adding two functions together, multiplying two functions together, dividing one function by another, subtracting one function by another. What if I want to plug one function, though, into another, right? What if I plug one in for another? That's called a composition of functions. So this is where you get Fogg and Goff, right? So as one of my calculus students immediately told me, Fogg off. Haha. Haha. No, okay. You guys are so dead. Come on. This is like Monday. It's going to be a short week. Guess what happens at 12:25 on Wednesday? Yeah, you're done with school. Okay. Whatever. So, if you have f of g of x, literally what you're doing is you're plugging all of g of x function in for every x in the f function. This is literally Fogg. And notice it's not a filled little circle that's multiplying. The O means composite. Okay. Similarly, if you had like g of f of x, this is where you have your Goff. Because you're literally plugging whichever one is second is the one you're like plugging in. It's the one you're taking, you're plugging in into the first equation. Cool. Okay, let's do this. Anything else I want to say about this? No. Okay, for each pair of functions, find Fogg, find Goff, and Fogg of 2. So, first one, I have 2x squared minus 1. So, I want to find Fogg. So what this means is I'm plugging g of x in for x in my f function. So I have 2 times x plus 3 squared minus 1. Then we just gotta simplify. That's all you do, right? So the second one is g of x. You're plugging all the stuff that g of x is equal to in for the x in your first function. So do not be lured into the trap of just distributing the square, because that's not true. You have to FOIL. X plus 3 times x plus 3 is not x squared plus 9. You're missing a plus 6x in the middle. I know you guys. Gotta actually FOIL it out. X squared plus 3x plus 3x plus 9. So this is equal to 2 times x squared plus 6x plus 9 minus 1. Just put this in a little like cloud bubble. So this is equal to 2x squared plus 12x plus 18 minus 1. We're almost there. So fog, right, f of g of x, you're literally plugging in g of x in for f. That's just going to be 2x squared plus 12x plus 17. See if you can find Goff. Go ahead, find Goff. So this time you're plugging this whole thing in for x. No, this is fine. Because we're not trying to factor and solve. We're just trying to like simplify by combining like terms. And then lastly, if I'm wanting the fog of 2, f of g of 2. So what I want to do is find g of 2. Okay, so that's just going to be 2 plus 3, which is 5, and then plug that into my f, my function. Plug 5 and take f of 5. So this is equal to 2 times 5 squared minus 1. So that's 25 times 250 minus 1 is 49. What?
Wouldn't it be 2 squared, not 5 squared?
No, because we plugged in 2 into g of x, right? Found what our value is, and then plugged that y in for x into our f function. Cool. Let's try the next one. Do we have questions about this? Me? Okay. Let's try the next one. So, fog, Goff, and fog of 2. So, fog. What we're going to be doing is plugging in all of this in for x. So this is going to be square root of x minus 1 squared minus 1. So I have to FOIL that out. X squared minus 1 times x squared minus 1 is x squared minus 2x plus 1 minus 1. Alright, because don't forget about that minus 1 that was already there. So this will just be square root of x squared minus 2x. That's it. Can't simplify it anymore. If you're done, try to find Goff.
Why can't you get rid of the square root with the
Square? With the square, you can't because this is a binomial. It's subtracting 1. Something squared minus 1. If this wasn't there, I could. But it's because I have that minus 1, I can't just...
Can't you just do like x minus 1 plus that?
No. Nope. Because it's a binomial. It has nothing to do with it being negative. It's because you have to do this first before you can do the exponent of 1/2, which is square root. Okay, now I'm plugging in f and for x. So this is equal to, let's see, square root x minus 1 squared. Ooh, so once again it's a binomial. Because you have square root x minus 1 multiplied by root x minus 1, right? Oh, this is going to be nasty. So I'll write out the binomial for you. So let's go ahead and let's FOIL. First, I'm going to have root x minus 1 squared, because you're multiplying it by the same thing, minus root x minus 1 minus root x minus 1 plus 1. So I FOILed, and so the square and the square root cancel out. I have x minus 1 minus 2 root x minus 1 plus 1. This is being multiplied because there's 2 of these. Minus 2 times this whole thing because there's 2 of them. So minus 1 plus 1 go away. I have x minus 2 root x plus 1. Oh, is there a minus? There's a minus under the radical. I'm sorry, it's x minus 1. And then lastly, if we want fog of 2, first plug in 2 into g of x, so that way I have 2 minus 1 squared, so that's just 1 squared, which is 1, and then we'll use that number and plug it into f of x. So f of 1 is equal to root 1 minus 1, so that's just root of 0, so that's 0. Awesome. So we got through a lot today. We only have 1 page left, which we'll finish tomorrow. Pretty rad. So tomorrow we'll for sure finish this in like, I don't know, 10 minutes or so. And then you can have time to work on your homework and quiz and Alex. Awesome.